A comet that shouldn't exist just forced the James Webb Space Telescope into emergency mode, and its data confirms a chemical nightmare breaking every rule in the book. The numbers are terrifying astronomers, pointing to something far stranger than a simple interstellar visitor. Is this object even natural, or is something else hurtling straight for us? The stakes only get higher from here. Let's explore this together. Emergency override, Webb's unprecedented response. What does it take to derail the most powerful space telescope ever built? On August 6, 2025, we found out. The James Webb Space Telescope slammed into emergency mode, pausing its entire science program for the first time in years. This wasn't a scheduled observation, it was a high-stakes director's discretionary time override. A procedure so rare it's only the fourth such event since launch in 2021. The target, an interstellar object designated 3Y Atlas, ground-based telescopes had just flagged it for accelerating in ways no one could explain, its spectrum flashing with unexpected metals. The call was authorized directly by the Space Telescope Science Institute director, Dr. Kenneth Sembach. The chain of command was short and swift, bypassing the usual committees that schedule Webb's time months in advance. The risk was immense. Webb's schedule is a precise ballet of fuel and orbits. A single, unplanned maneuver to observe a target for 5.3 hours could cost a week of other science. But the window to catch 3I Atlas was closing fast. Its trajectory was shifting by the hour. The command was uploaded and the telescope pivoted, its near-infrared spectrograph NIRSpec, locking onto a target that was rewriting astrophysics in real time. This wasn't a routine target of opportunity, it was a scramble to observe an object challenging our fundamental understanding of visitors from other star systems. Early activity beyond Jupiter's orbit. Here's where the story gets strange. Comets are supposed to be dormant deep freeze travelers. They wake up when they get close to the sun, typically inside Jupiter's orbit at 5 astronomical units. But 3I Atlas started showing activity far out, at 6 AU from the sun. That's nearly 900 million kilometers away, where temperatures hover around a frigid 110 Kelvin. The first hints came from the Pan-STARRS survey in Hawaii, led by Dr. Ken Chambers, which noted a faint, persistent brightening. It wasn't just a flash, the object was waking up. Then the 8.1-meter Gemini South telescope in Chile confirmed it. 3I Atlas was already sprouting a tail, a ghostly limb of gas stretching hundreds of thousands of kilometers. This is not how comets are supposed to behave. For comparison, 2I Borisov, discovered by amateur astronomer Gennady Borisov, began its activity much closer. The early outgassing of 3I Atlas suggested its engine wasn't the sublimation of water ice. Something far more volatile was driving this activity, a clear sign this visitor came from a place with a very different chemistry. It was the first clue that 3I Atlas was a messenger carrying a very strange message, one that began long before it should have. The carbon dioxide anomaly. The moment Webb's NIRSpec instrument locked on, the chemical picture came into focus, and it was a shock. The spectrum was overwhelmed by carbon dioxide. In the cold depths of space, CO2 ice turns to gas at much lower temperatures than water ice, explaining the early activity. But the sheer quantity was staggering, with a production rate exceeding 10 to the 28th molecules per second. Webb's data revealed a carbon dioxide to water ratio of 8 to 1. Let me put that in perspective. A typical comet from our solar system like Hale-Bopp has a CO2 to water ratio of about 20%, or 0.2 to 1. The interstellar Comet 2I Borisov had a ratio of about 0.4 to 1. 3I Atlas was 20 times more CO2 rich than Borisov. As Dr. Neil Della Russo of Johns Hopkins APL, an expert in cometary composition, would note, this is completely unprecedented. The data was undeniable, with the telltale signature of CO2 at a wavelength of 4.26 microns burning bright and broad. Water was there, but only as a faint afterthought. This wasn't just a comet with extra CO2, it was a body fundamentally built differently, pointing to a birthplace where water might be a trace element, a type of protoplanetary disk our models barely account for. Nickel without iron, an impossible chemistry. But the carbon dioxide was just the appetizer. The main course was a chemical puzzle that, honestly, sent shockwaves through the astronomical community. Webb's spectrum showed clear, strong signatures of metallic nickel. At first, the team suspected an instrument artifact, but the lines held firm, confirmed by the Very Large Telescope's UVES spectrograph, operating at a resolving power of 80,000. The nickel was real, with a production rate of, get this, 10 to the 21st atoms per second at 3.8 AU. But here's the impossible part. There was no iron. In every celestial body ever studied, the cosmic abundance ratio is about 15 parts iron to 1 part nickel. 2. I Borisov followed this rule. 3. I Atlas shattered it. The data showed that nickel outnumbered iron by more than 40 to 1. Imagine finding a pure platinum nugget with no trace of other platinum group metals. That's the scale of this anomaly. Spectroscopists like Dr. Dennis Bodowitz, an expert on cometary composition, would be stunned. The nickel lines at 3415, 3524, and 3525 angstroms were unmistakable, but the spectrum was flat where iron should have been. One fringe theory suggests the formation of nickel carbonyl, a highly volatile molecule, but for this to happen without its iron equivalent defies all known astrochemistry. Trajectory anomalies and acceleration spikes. As the chemical data was being analyzed, the teams tracking the comet's path were facing their own bewildering problems. 3I Atlas was not following the clean, predictable arc of gravity. It was accelerating, showing a non-gravitational change in velocity of nearly 0.12 meters per second squared over just 72 hours. While comets do this, the force is usually gentle. The acceleration of 3Y Atlas, however, wasn't smooth. The trajectory, tracked by the Minor Planet Center, showed tiny, sharp jumps. This recalled the mystery of Oumuamua, whose own non-gravitational acceleration was famously detailed in a 2018 paper by Marco Michelli. But this was different. For an object estimated to be 11 kilometers across, this is like watching a mountain suddenly shift course. The Pan-STARRS survey team ran every diagnostic, checking for software bugs or errors in their astrometry. The data was solid. The acceleration was real. It meant the forces acting on 3I Atlas were not just coming from the sun. Something else was at play, something internal, or something about its structure that allowed it to move in a way that defied our models, deepening the mystery and fueling speculation that this was no ordinary cosmic iceberg. The lighthouse effect, mechanical light curves. The weirdness didn't stop with its chemistry or its path. The way 3I Atlas reflected sunlight was just as puzzling. Photometric data from Gemini South and the TESS Space Telescope revealed a periodic brightening, a sharp pulse of light that repeated every 7.2 hours with almost mechanical regularity. It was like a lighthouse beam. A slow, gentle tumble is expected from an outgassing comet. But this was different. The brightness changed by over 2 magnitudes, a factor of 6, which is an extreme variation. The period was too constant. Dr. Karen Meach of the University of Hawaii, who led the team that characterized Oumuamua's wild tumble, would find this regularity highly unusual. For a normal comet, the spin should slow as it loses mass. But the 7.2-hour period remained locked in. Astronomers tried to model it as a spinning, elongated object, but the sharp rise and fall of the light curve didn't fit well. Other models suggested a hollow or even a sheet-like structure with sunlight glinting off a large, flat, reflective surface. The parallels to Oumuamua were impossible to ignore, but 3I Atlas was bigger, brighter, and its light curve was even more pronounced, more rhythmic, pushing the boundaries of what a natural object could be. Ancient sky metal, historical context. So, the idea of metal falling from the sky isn't new, it's really woven into our history. Around 3200 BCE, ancient Egyptians hammered beads from iron they couldn't possibly have smelted. Analysis of artifacts from the Giza tombs reveals the secret. The beads contain nearly 30% nickel. No terrestrial ore has that composition. The only source was a rare type of meteorite called an ataxite, and actually a similar story is found in Tutankhamun's tomb. Buried with him was a dagger with a blade of meteoritic iron containing 11% nickel and 0.6% cobalt, a composition detailed in a 2016 study in meteoritics and planetary science. This iron from heaven was incredibly rare. The Babylonians also watched the skies, and their cuneiform tablets speak of burning stones as omens. The Akkadian word for iron and bar comma is sometimes translated as sky metal. These cultures didn't understand the chemistry, but they knew this metal was different, special, and came from beyond their world. They understood that when the sky delivers something new, it can be both a wonder and a warning. Today, astronomers use powerful telescopes, but the core question remains, when an object arrives with a signature that defies explanation, what message is it bringing? Avi Loeb's challenge to consensus. As the data on 3I Atlas circulated, one voice cut through the cautious scientific debate: Harvard astrophysicist Avi Loeb. He had already made waves with his controversial hypothesis that Oumuamua could be an extraterrestrial artifact. Now, faced with 3I Atlas, he was even more direct. In a widely read blog post, he posed a blunt question: what natural process can produce a comet with pure nickel and no iron? He pointed out that separating these elements requires complex industrial processes. In the cosmos, it's considered impossible. Loeb connected the dots: the impossible chemistry, the erratic acceleration, the clockwork light curve. He argued that we must consider the possibility that we are looking at technology, a central mission of his Galileo project. His critics urged caution, but Loeb's position is that the anomalies themselves are the evidence. He contends that clinging to a natural origin explanation when the data contradicts it is unscientific. His challenge forced the conversation into the open, pushing the debate beyond academic journals and into the public square, demanding that the artificial hypothesis be considered on its own merits. Scientific community divided. The case of 3I Atlas split the astronomical community. On one side were scientists working to find a natural, if exotic, explanation. Dr. Alan Stern, principal investigator of the New Horizons mission, had previously proposed that Oumuamua could be a nitrogen iceberg from a Pluto-like exoplanet. Perhaps 3I Atlas was a carbon dioxide iceberg from a similar world. Others, like Comet expert Dr. Matthew Knight, argued that the non-gravitational acceleration could still be explained by powerful localized jets. On the other side were those emboldened by Loeb, who argued that we had to take the artificial origin hypothesis seriously. They pointed out that a light sail, a thin reflective sheet, could neatly explain both the sharp light curve and the acceleration. No one was claiming definitive proof, but the idea that 3I Atlas might be a probe, or a fragment of one, was no longer a fringe theory. It was being actively discussed. Peer-reviewed journals and online forums buzzed with debate as every new piece of data was scrutinized. The object was a cosmic Rorschach test, and what you saw depended on how willing you were to challenge fundamental assumptions about our place in the universe. NASA's high anomaly classification. Behind the scenes, the official response was one of cautious urgency. While public statements remained measured, NASA's Planetary Defense Coordination Office, led by Officer Lindley Johnson, quietly flagged 3I Atlas with a special designation high anomaly. This classification is typically reserved for near-Earth objects whose behavior is unpredictable. But in this case, it was for an object whose very nature was in question. It wasn't a threat in terms of impact, but it was a scientific wildcard of the highest order. Internal risk assessments using systems like Sentry-2, usually focused on collision probabilities, were repurposed to track an enigma. The official line from NASA remained consistent: more data is needed. Extraordinary claims demand extraordinary evidence. Yet in private, even the most skeptical scientists admitted this object was unique. The data was being triple-checked and distributed to a wider network of researchers. But until a consensus emerges, 3I Atlas remains an official mystery, an object whose strange behavior has earned it a unique place in NASA's catalog of cosmic visitors. So, what is 3I Atlas? Is it a cosmic fluke, a messenger from a type of star system whose chemistry is alien to us? Or is it something more? The evidence is tantalizing and deeply unsettling. An object that moves on its own, shines with a mechanical rhythm, and is made of materials that shouldn't exist in nature. It could be the first definitive proof that we are not alone in the universe, a piece of technology from a civilization far beyond our own. For now, the answer hangs in the balance, locked in the data, awaiting the next observation that could finally tip the scales. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. What do you think 3I Atlas is? Let us know in the comments below. Thank you for watching Sci and Why.